Hello and welcome to edupediaworld.com, your favorite portal for online education. In the last session, we had started with mode. We had seen how to calculate mode along with the definition, but the calculation was confined only to ungrouped frequency distribution. Today, we shall see how to calculate mode for grouped frequency distribution. In the last session we had seen how to calculate mode by method of inspection and method of grouping. We use method of inspection when the data is regular, and we use method of grouping when the data is irregular. Regular in the sense that the frequency of the data increases and decreases gradually, whereas if it's not regular, if it is not increasing and decreasing gradually, or if there are more than one peak and all the other cases, then the data is said to be irregular. Now, even for the grouped frequency table, we have the same two methods. In case if the data is regular, we will be using the method of inspection, and if the data is irregular, we will be using the method of grouping. But the difference is that in grouped frequency, we will only get the model class and not the mode from the table, and then we will be using the interpolation formula to find the mode. So let me give you the formula to find mode, and then we will take up some numerical problems. The formula to find mode using method of for the grouped frequency using the interpolation formula is lower value of the model class plus delta 1 divided by delta 1 plus delta 2 multiplied by h. Of course, you are familiar with some of the nomenclature because we see that the pattern is same as that of median. Let me explain it to you once. Now, LMO stands for lower value of the model class. When we have a class, say for example from say 30 to 40, this is the lower value and this is the higher value. Okay, and we know h is the width of the model class. What about delta 1 and delta 2? Well, delta 1 is given by frequency of the model class. Let me write it as Fm minus frequency before the model class. Let me give 1. Let me write it here. Fm stands for frequency of the model class, and F1 stands for frequency before the model class, and delta 2 is equal to frequency of the model class minus frequency after the model class. Let me write it as f2. It's frequency after the model class. Okay, so now if I substitute the value of delta 1 and delta 2 here, I can also write my formula this: mode equals lower value of the model class plus, in place of delta 1 I can write fm, that is frequency of the model class, minus frequency before the model class. Frequency of the model class minus frequency before the model class. Of course you can also use say, instead of f1 you can say since it is before, just to avoid confusion, you can also write it as fb and fa. I mean, it's up to you, whichever you feel is comfortable, you are comfortable with, you can use them. I'm using 1 and 2 here, so it will be fm minus f1 divided by, now let me do it once, delta 1 will be fm minus f1 plus delta 2 will again be fm minus f2, and the whole thing multiplied by h. So this further can be written as lower value of the model class plus frequency of the model class minus frequency before the model class divided by, see here we have fm twice, so we can add them and write as 2 fm minus f1 minus f2, and the whole thing multiplied by h. Okay, so now it's up to you, you can use whichever formula you want. Let me just highlight this. This is the formula, it's one and the same. Can you just keep in mind the one which you feel is easier to remember. Okay, so let me just let us take a problem and solve it. Before that, before taking up any problem, let's just understand why do we use method of grouping when the data is irregular. We see that when the data is irregular, there is no clear-cut maximum value of the frequency. What happens is that you either have more than one maximum, or you have some flat maximum point instead of a sharp one like how we have here. So in these cases we will have to see which is the variable where the data is concentrated, and that is why we use the method of grouping, where we add the frequencies in groups and see which is the region which has the maximum concentration. Okay, alright, so now let's take a numerical problem and practice the problem with grouped frequency distribution. Well, here we have a data where the weekly wages of a certain number of workers are given. The first thing which we need to do is check whether the data is regular or irregular. Of course, that's to be done only after arranging this. So here we see that the data okay, let's draw this and see. We have the first frequency as 4, then it goes to 6, 20. So let's do it here. Let's say that we have the frequencies taken here. Just a rough sketch will do. First it is 4, then it goes up to 6, 20 and 12. Goes up to 6, gradually increasing, then 20, then coming down to 12, then again going up to 33, then coming down to say 17, 8 and finally 2. So we see that it goes up, again comes down, again goes up and again comes down. So of course this is very clear that this is an irregular data, and so we will have to use method of grouping. Fine, so now we know that for method of grouping we will have to draw 6 additional columns. Let me do that. In the first, what do we do? Exactly, we add 2 frequencies taken from the top. So this would be 4 plus 6, and the next one would be, again we can just copy this because the same pattern is followed. Okay, so these are the sum of the frequencies taken in groups of 2 from the top. In the next column we again take sum of the frequencies 2 at a time, but we don't take it from the top, we leave the first one and we take it from the second one. So we will have to add and write the first here. This will be the sum of 6 and 20. Okay, so next, continuing in the same way, we will have up to this. We will have the last one left blank because it's alone and we need to add 2 at a time. Okay, what do we do in the third column? Yeah, we add 3 at a time taken from the top. So we will add 3 at a time taken from the top. Yeah. And then drag it down to the next level. We don't have 3 left now, we just have 2, so we will not be able to add them further. In the fourth column we leave the first one and add the next 3. So we will have this as the sum of 6 plus 20 plus 12, and similarly just drag it down to the next level. And in the fifth column we again add 3, but after leaving the first 2. So 3 at a time, leaving the first 2. This would be the summation of 20 plus 12 plus 33, and then dragging it down to the next level. Yeah, we get it. Okay, next step, we take the maximum in each of these columns starting from this column. Maximum in each of these columns up to 5, and let me just highlight the maximum. So in this, here this is the maximum, here this is the maximum, here again 45 is the maximum, here 62, 58 and 65. Okay, so these are the maximums. Yeah. So now once we have got the maximum, we need to count and see which class has got the maximum number of maximums. First class, we see that there are no maximums, so it is 0. The second class, again we see that no maximum has fallen in here, so again this is 0. Third one we see once, well, only once, so once. And then fourth class we see is we have 1 maximum, 2 maximum, 3 maximums, so we have 3. Next, the fifth class has got 1, 2, 3, 4, 5 and 6. The maximum which you could get is 6, because you know that we are counting totally in 6 columns, so this has got that. And then the next one we have 1, 2, 3, only 3. Next is only 1. Here it's 0. Okay, so now we see that this is the maximum. So our model class is this one, the one corresponding to this, and that is from 400 to 450. So my lower value of the model class is 400. Lower value of the model class is 400. What about the width? Of course, width is of the model class is 50, because that's the difference between the lower and the higher value. And frequency of the model class, model class FM is 33. Frequency before the model class, which I use F1, is 12, and frequency after the model class F2 is 17. Okay, so we have all the data here. Now we are ready to calculate the mode. So let me do that here. Maybe mode. Oh, before that, okay, we can use any one of the formula. So mode will be equal to the lower value of the model class, which is this, plus, let me put that in parenthesis, you have frequency before delta 1 at the top. Delta 1 is the difference between frequency of the model class and frequency before the model class. So it is this minus that's divided by delta 1 plus delta 2. Now when we add them, we have seen that we will have 2 times frequency of the model class. So 2 times frequency of the model class minus before and after, and the whole thing needs to be multiplied by h, which is 50. Yeah, so the mode of this data is 428.378. Okay, maybe you could have taken the delta 1 and delta 2 separately also. Let me put it as D1 and D2. Your delta 1 is frequency of the model class minus frequency before the model class, and delta 2 is frequency of the model class minus frequency after the model class. So you can even use these values and calculate the mode using the first formula which I had given. Okay, so this is the working of a grouped frequency table. We had already seen the method of grouping, and this was a revision. Now we have seen how to use the formula to find mode. Fine. So let's take a question for practice, and you can do it yourself. Pause me for a while and see if you can find the mode of this data. Alright, so here again we have the marks and the frequency given. As usual, we will have to first check whether we need to use method of inspection or method of grouping. We will have to see whether the data is regular or not. Now in this case, when we see, by the way, we don't need to draw every time. I think by practice we will get to know that this data we will be able to find even without drawing the diagram that this is regular or irregular. In this case, when we see the data gradually increases from a smaller number 3, 5 goes to 12, finally to 18, and in the same way finally it again slides down to 14, 6 and 2. So we see that the data is very much regular, and you were lucky that you have got a question which is regular. You don't need to draw the grouped table. So here of course the maximum frequency corresponds to this class. So this is our model class. Okay, maximum frequency. Let me write that here, maximum frequency, and so this is our model class. Okay, but we see that the data starting from 30 goes up to 34, and then there is a gap of 1. The next class starts from 35, goes up to 39, then 40 to 44, 45 to 49, and so on. So we see that every subsequent class differs by a value of 1. There is one unit which is missing or which has formed the gap. So we will have to first rearrange this data into class boundaries, as we used to do for median. And how do we do that? Exactly. We take the difference. Now we see that the difference between this end of this class and the start of the next class is 1. The difference is 1. We need to divide that difference by 2 and add half of it here to the upper limit of the first class and subtract another half from the lower limit of the next class. So that way when we do, we will have the first class starting from 29.5 and it will go up to 34.5. The next class would be from 34.5 as we subtract half from the lower value, and that will go up to 39.5 when we add half to the upper value. The next one would be from 39.5 to 44.5, then 44.5 to 49.5, 49.5 to 54.5, 54.5 to 59.5, and finally 59.5 to 64.5. Okay, so we need to arrange the class boundary, and always bear this in mind because it's maybe just for the sake of looking at the regularity of the data, you may forget at times. So we need to arrange the data in the continuous form by rearranging the class boundaries. And now our lower value of the model class is 44.5 and not 45. Okay, so let me write that here. Lower value of the model class is 44.5. Height or width of the model class is, again we will have to see the difference between this and not this, though here it's 4, here we see it is 5, so width is 5. Next we can take the frequency values. Frequency of the model class, which we see here, is 18. The frequency before the model class, and that is 12, and the frequency after the model class, which is 14. Okay, then we can calculate the delta values. Delta 1, which is the difference between the frequency of the model class and the frequency before that. so it is 18 minus 12, and delta 2, which is the difference between Fm, which is 18, and the frequency after the model class, which is 14. Now we are ready to calculate the mode. So the mode is given by the lower value of the model class, plus the delta 1 value divided by delta 1 plus delta 1 plus delta 2, and the whole thing multiplied by h, which is 5. So that gives me the mode, which in this case is 47.5. That's all we have in this session. We are still left with some special cases of calculation of mode, which we will take up in the next class, in the next session. Keep watching edupediaworld.com. Thank you.